Hey everyone, welcome to another episode of Robotics Innovations. In this episode we are going to see top mind-blowing robots. Before we start, please click the subscribe, as 95% of video viewers not subscribed to this channel, and of course click the bell icon to get notifications on new video release. FRIDA Painting Robot. Painting is an artistic process of rendering visual content that achieves the high-level communication goals of an artist that may change dynamically throughout the creative process. FRIDA, a robotic arm with a paintbrush taped to it, uses artificial intelligence to collaborate with humans on works of art. Ask FRIDA to paint a picture, and it gets to work putting brush to canvas. FRIDA, named after Frida Kahlo, stands for Framework and Robotics Initiative for Developing Arts. The project is led by Schaldenbrand with faculty members Jean O and Jim McCann, and has attracted students and researchers across CMU. Users can direct FRIDA by inputting a text description, submitting other works of art to inspire its style, or uploading a photograph and asking it to paint a representation of it. The team is experimenting with other inputs as well, including audio. They played ABBA's Dancing Queen, and asked FRIDA to paint it. FRIDA is a robotic painting system, but FRIDA is not an artist. FRIDA is not generating the ideas to communicate. FRIDA is a system that an artist could collaborate with. The artist can specify high-level goals for FRIDA, and then FRIDA can execute them. The robot uses AI models similar to those powering tools like OpenAI's ChatGPT and DALL-E 2, which generate text or an image, respectively, in response to a prompt. FRIDA simulates how it would paint an image with brushstrokes and uses machine learning to evaluate its progress as it works. FRIDA's final products are impressionistic and whimsical. The brushstrokes are bold. They lack the precision sought so often in robotic endeavors. If FRIDA makes a mistake, it riffs on it, incorporating the errant splotch of paint into the end result. FRIDA is a project exploring the intersection of human and robotic creativity. FRIDA is using the kind of AI models that have been developed to do things like caption images, and understand scene content, and applying it to this artistic generative problem. FRIDA taps into AI and machine learning several times during its artistic process. First, it spends an hour or more learning how to use its paintbrush. Then, it uses large vision language models trained on massive data sets that pair text and images scraped from the internet, such as OpenAI's contrastive language image pre-training, CLIP, to understand the input. AI systems use these models to generate new text or images based on a prompt. Other image-generating tools, such as OpenAI's DALL-E 2, use large vision language models to produce digital images. FRIDA takes that a step further and uses its embodied robotic system to produce physical paintings. One of the biggest technical challenges in producing a physical image is reducing the simulation to real gap. The difference between what FRIDA composes in simulation and what it paints on the canvas. FRIDA uses an idea known as Real 2 Sim 2 Real. The robot's actual brushstrokes are used to train the simulator to reflect and mimic the physical capabilities of the robot and painting materials. FRIDA's team also seeks to address some of the limitations in current large vision language models by continually refining the ones they use. The team fed the models the headlines from news articles to give it a sense of what was happening in the world, and further trained them on images and text more representative of diverse cultures to avoid an American or Western bias. This multicultural collaboration effort is led by Zhixuan Liu and Beverly Claire Okagwu, first-year Remasters students, and Yuean Shin and Youngshik Yun, visiting master's students from Dongguk University in Korea. Their efforts include training data contributions from China, Japan, Korea, Mexico, Nigeria, Norway, Vietnam and other countries. Once FRIDA's human user has specified a high-level concept of the painting they want to create, The robot uses machine learning to create its simulation and develop a plan to make a painting to achieve the user's goals. FRIDA displays a color palette on a computer screen for a human to mix and provide to the robot. Automatic paint mixing is currently being developed, led by Jiaying Wei, a master's student in the School of Architecture, with Yoonsu Kong, faculty in the Machine Learning Department. Armed with a brush and paint, FRIDA will make its first strokes. Every so often, the robot uses an overhead camera to capture an image of the painting. The image helps FRIDA evaluate its progress and refine its plan, if needed. The whole process takes hours. People wonder if FRIDA is going to take artists' jobs, but the main goal of the FRIDA project is quite the opposite. We want to really promote human creativity through FRIDA. For instance, I personally wanted to be an artist. Now, I can actually collaborate with FRIDA to express my ideas in painting. EDAG CityBot. The EDAG CityBot is an autonomous vehicle using fuel cell propulsion and moves across the city in a climate-friendly manner. The goal of this project is to show how fully autonomous vehicles could work in futuristic cities. However, the special feature of the CityBot is that it would never stand still and has been designed to use urban resources efficiently. The EDAG CityBot could be used for a variety of different applications such as a group taxi, a cleanup vehicle, a supermarket hero, a delivery vehicle, or a party vehicle. In this case, the IOTA blockchain will play the role of maintaining secure communication and micropayments. As per the estimates, this project will contribute to $80 billion in smart city revenue by 2026. The CityBot is an innovative vehicle. Its infinite variants range from passenger transport, such as a current airport shuttle for example, to the public garbage disposal service, obviously passing through even more professional uses. There is also the variant dedicated to street cleaning, and the version for the maintenance of the city's green areas. Particularly the van bodywork, for transporting goods, and the party, one for meetings or parties on the move, equipped with a low-floor bodywork that allows you to stand inside it, like current buses. A new ecosystem. What makes this vehicle unique? The fact that the front part with the electric motor, equipped with 4 wheels, is an independent part of the vehicle. It can be detached and connected to all the body variants mentioned above to make full use of the van, an absolute novelty in the world landscape. This configuration allows a company, for example, to own a single vehicle dedicated to several tasks, which saves space, time, fuel and above all significantly reduces Colorado II emissions into the atmosphere. EDAG predicts that within a few years these will be the vehicles we will see the most in our cities. Hydrogen propulsion. EDAG CityBot is an intelligent, multifunctional and fully autonomous vehicle that moves without emissions through fuel cell propulsion. Together with platform technology for the Internet of Things and, for example, the digital micropayment solutions of EDAG partner IOTA, EDAG CityBot not only launches new autonomous transport and work vehicles, but also possible new business models. For testing in a real environment, a real laboratory, a small-scale smart city, is being built on the Deutsche Bank Park site. The project name, Campus Free City, examines how the city of the future will be sustainably influenced by new fields of technology, such as artificial intelligence, the Internet of Things or autonomous driving. Technologically, the Campus Free City focuses on the data technology networking of the EDAG CityBots with a central mobility backend. A redundant environment sensor, including 3D cameras and lidar sensors, ensures safe operation. In the societal context, it is important to identify possible concerns people have and to gain trust by focusing on possible uses and sustainability. Through public dialogue, human-machine collaboration should gain acceptance among the general public, for a better quality of life and against inner-city traffic congestion. Toilet cleaning robot. Giddel is essentially plug and play and walk away. Begin by placing your regular toilet bowl cleaner in the toilet bowl. Plug in Giddel and press play. At the beginning of each cleaning cycle, Giddel extends its arm and touches different surface points to calibrate Giddel's advanced sensors to map the surfaces of the toilet for an optimal clean. Giddel cleans systematically from least dirty to increasingly dirty regions, starting at the top of the toilet rim, the inner rim, under the rim, and all the way down the entire toilet bowl, all in a few minutes. Once the cleaning cycle is complete and Giddel has moved back to its starting position, press the red release button to unplug Giddel and place it in its charging station for storage, or take Giddel to another toilet to clean. Giddel is a compact, lightweight and cordless robot, so you can easily take it to every bathroom in your home to make every toilet spotless. The Giddel robot is suspended over the toilet, never itself contacting the toilet except for the replaceable brush. The Giddel robot is doped with antimicrobial compounds. Considering both facts above, Giddel stays hygienic. If you wish, whenever you want, you may clean the robot with a dry and/or damp and/or antimicrobial wipe. The Giddel brushes are cleansed with the toilet bowl cleaning liquid and rinsed out at the end of each toilet cleaning cycle. The Giddel brushes are very durable and long-lasting. If they should become noticeably dirty, the Giddel brushes are replaceable. The robot included safety features such as the Giddel safety switch, which will not turn on unless it is mounted securely in the toilet. Giddel's obstacle detection and navigation functionality makes Giddel child and pet friendly. The use of Giddel's reservoir is entirely optional. Using the refill bottle, you may pour water into the reservoir. During cleaning, the water from the reservoir exits through the robot arm and the brush onto the toilet rim surface to clean off any dirt or toilet bowl cleaning liquid from the rim. Giddel has been tested under laboratory conditions to clean 3 toilets once a week for 3 years. A flying robotic SPIDAR. Robots with multimodal locomotion capability are almost always a compromise, because usually they're a hodgepodge of mobility systems that don't really work together. It'd be possible to make a legged robot fly by stapling a bunch of propellers to it, but at any given time, either the legs or the propellers are going to be mostly just awkward extra mass. Some robots make this compromise more elegantly than others, but it's still a compromise. A new quadrupedal robot under development at the University of Tokyo called SPIDAR aims to minimize this compromise by combining legs and propellers and relying on that combination for both walking and flying locomotion. Instead of leg actuators, it's got vectorable leg thrusters that can both move leg joints individually and get the entire robot completely airborne. SPIDAR, in what is perhaps one of the worst backronyms of all time, stands for Spherically Vectorable and Distributed Rotors Assisted Air-Ground Amphibious Quadruped Robot. It is absolutely not a spider, since it has 4 legs rather than 8, but it does look sufficiently leggy to set off a similar squick response. It's generally true that if there are enough thrusters on a thing, that thing can become airborne. What's really difficult is controlling it, and then doing something useful. And it gets even more difficult when you've got all kinds of wibbly-wobbly interconnected degrees of freedom that require constant management, as is the case with SPIDAR. And it's pretty easy to tell that this is really just a functional prototype at the moment, since it seems to be perpetually on the verge of tearing itself apart. Science. Each of SPIDAR's limb sections has a spherically vectorable dual thruster attached. These thrusters can roll around the limb as well as rotating orthogonally to it, providing thrust in any direction. The joints do currently have small servos to actuate them a little bit, but this is mainly to simplify the dynamics of the system in order to run everything on board. The servos aren't strong enough to support the weight of the robot, and its mobility does depend primarily on the thruster system. In total, SPIDAR has 8 links with 16 joints, and weighs in at a hefty 15 kilograms, which includes 8 batteries distributed along the links. Total flight time is 9 minutes, and the robot can walk for more than double that. Calling SPIDAR a legged robot might be a little short-sighted, since in their paper, the authors point out that the limbs could also be used for either terrestrial or aerial manipulation. It's going to take some work to make it a stable enough platform for that, but the researchers are already hard at work on it. Thanks for watching. Please like, share and subscribe video. Also hit the notify button to get instant updates on new video alerts.